Hello, I'm processing an astrophoto of M31, the Andromeda galaxy, and wanted to record a technical note about the order of operations, the order of steps in image processing. It comes useful in my research as well in fluid mechanics when we do quantitative flow visualization in the lab. This particular astrophoto is an LRGBH dataset. So the images of the same object are captured through luminance, red, green, blue, and narrowband hydrogen alpha filters. The luminance is a broadband but not a neutral filter. It cuts off some of the UV and infrared emission, but it has much higher signal-to-noise ratio compared to the data collected through other filters. So it's basically the camera is capable of collecting more photons per unit time through the L filter, and as a result it kind of provides the structure of the object. It's not colored, but the dust lanes, the filaments, the galactic core are much better resolved. The contrast and the intensity of the image is generally better, and then subsequently it's combined with other channels and colored. But one could argue that the information in the other channels could be integrated into that image also to further enhance the level of details. And that is what we call the construction of so-called super-luminance image. That is easily done, but my question was whether to remove the stars from the image before or after that step. And the star removal is nowadays a standard kind of step in image processing because stars are much brighter than the gas emission regions or the other aspects of most astro targets. If we apply the same processing pipeline, so the stretch, for example, images to the same degree, the stars and the other structures would be completely different. The stars would get blown out, the color information would be lost, and just generally the image would be not very appealing. So typically we can apply an algorithm such as star exterminator in PixInsight, for example, to produce a starless and a star field separately, apply different processing workflows to them, and then recombine them. So the question is whether to produce a superluminance before removing the stars for further processing or after. And I looked into this, and it seems to me that definitively the formation of the superluminance should be done before the stars are removed. And there are a couple of reasons, but mainly because the superluminance is more than the cosmetic enhancement of the image details. It actually is a statistical estimate of the importance of the information that was transmitted from parts of the object. And if we remove part of the signal, that frequency is going to be lost. So when we recombine the channels, we'll get the different result mathematically than if we preserve that information. So that is quite important if we're after more physically correct representation of the object. Also, the images of the stars, they're useful for other processes that are done in a linear state before the histogram is stretched. So for example, deconvolution, which is the reconstruction of the spread of the light as it passes through atmosphere and the telescope optics, relies on the estimate of the image quality, which is often expressed. One of the parameters that characterizes it is so-called PSF, point spread function. It's basically the size of a typical star in pixels in the resulting image. So for normalizing the different channels, the calculation of the PSF in each of them is useful. So it's good to have star images in each channel while they are combined into the superluminance. So having said that, there is no right answer if we're after just artistic kind of representation of Andromeda Galaxy or whatever other object we're photographing. The beauty of astrophotography as kind of artistic pursuit is that there are so many post-processing steps that allow creative decisions, and I've seen images online that are absolutely beautiful, and they follow different order of operations, different workflows. So this is definitely not a tutorial, but if we are after kind of scientific precision, then arguably this preserving the stars before producing the superluminance is physically more correct and certainly mathematically more accurate. That is useful. I'm kind of glad that there are these artistic pursuits of astrophotography. They inform scientific results also in the lab. There is the cross-pollination between the science, engineering, and art, and I think this is fascinating. So stay tuned for the final image of this target and more kind of insights that come up along the way.